Dr. Godez. So what do we have for today's pre-class?
So for today's pre-class video, I want to talk just really briefly about redox chemistry and then about solution stoichiometry.
Okay.
So, last class period, we talked about acid-base chemistry, one of the fundamental types of reactions. And in acid-base chemistry, a hydrogen ion, an H plus ion, moves from the acid over to the base. So H plus is moving. In a redox reaction, we're not moving H pluses, we're moving the other simple particle. What's moving in a redox reaction?
It would be the electrons.
Yep. Electrons move. So acid-base, you're moving an H plus, a proton. In redox chemistry, we're moving electrons. So it's really important in redox chemistry to follow the charge, because that's going to tell you where the electrons are moving. Right? So I've written up a redox reaction here. Iron solid reacts with aqueous silver, and this is a net ionic equation because I haven't put the counter ion, the anion that goes with that, but it doesn't matter. The products are solid silver and then iron aqueous. So to get from iron to iron 2 plus, what has to happen to that atom?
Well, we noticed that this iron doesn't have a charge on it,
Yep.
right? So it's net neutral. That means its protons and its electrons are the same number.
Yep.
But if it's 2 positive here, that means there's 2 more protons than there are electrons. So that means it lost 2 electrons somehow.
Yeah. Right. The protons don't change. That's in the nucleus of the atom. What's changing are the electrons, the number of electrons. So this lost 2 electrons. Okay, well, they don't just lose it. They have to go somewhere, right? And that's why it has a redox partner. Silver ion going to silver. Well, to start out with a positive charge, the nucleus doesn't change, so the only way to cancel that positive charge is if that gains electrons, right? And plus 1 to 0 means that this is going to
Gain 1 electron.
gain 1 electron. Okay, well, if that gains 1 electron, that lost 2 electrons, there's a problem, right? We have 1 extra electron. This lost 2, that only gained 1. What are we going to do about that?
Well, then I guess we have to balance this equation.
Yeah, we have to balance this equation. And there are 2 ways to think about this. One is that the number of electrons lost has to equal the number of electrons gained. And so that means that I'm going to need twice as many silver ions as I have iron atoms. The other way to do it is that not only do the atoms have to be balanced on both sides of a reaction, but the charges have to be balanced as well. Right? So we have a total of 2 plus charges over there. We have a total of 1 plus charge over here. I can't just add charges randomly because that changes the identity of the species. So I have to put a 2 out in front in order for the charges to balance out. Since we started with 2 silvers there, I need a 2 there. That doesn't change the charge, right? So I'm still good.
Right, and just like when we first learned how to balance reactions, you want to put the 2 in front of the compound, because if you put it here, that's changing what the compound is.
Right. If I put a 2 down here, that would mean that the silver ions were actually stuck together, or silver atoms were stuck together. This says that they're just 2 of them, 2 silvers. Okay? So the second part, and so you'll move through this and keep track of electrons, keep track of charges. Redox chemistry is actually really important. Redox chemistry, metabolism is all redox chemistry. Batteries are all redox chemistry. Corrosion is redox chemistry. Combustion reactions, redox chemistry. It's all over the place. So it's a really important class of reactions. So the other part of the activity is going to be stoichiometry.
It's back.
It's back. Solution stoichiometry. And so what I want you to do before class is review the big M. What is the big M? Molarity.
Yes.
Right? Review how to calculate molarity given grams and volumes. Review how to get moles from volumes and molarity. All those things, you're going to need to be able to do them in class. And if you're trying to learn that at the same time that you're learning the stoichiometry, it's going to be difficult. So spend a little bit of time. In fact, on the pre-class quiz, I'm going to ask you to do a molarity problem. Yeah.
Hey, you're warned.
Little tip.
You know.
Okay, so good luck.